Hi, this is Rich from RWN Labs, and welcome to my entry to the Flashing Light Prize 2017. Now, my approach to this problem is to actually count the number of photons emitted from this filament lamp and use that number to determine how long the lamp is switched on for. So, how have I gone about doing this? Well, firstly, light gets passed through what we call a natural density filter. This is nothing special. In fact, this was brought off eBay and generally used for photography. And this particular ND filter is contained in a 3D printed housing I've created. And you can essentially think of this as acting like a volume control, but for light. It's going to control how many photons are allowed to pass through it. So we can control how many photons come from this side, i.e. from the light bulb, and from surrounding ambient room light, and are coupled into this multimode fibre here. Now, once the photons have traversed down this multimode fibre and have reached the single photon detector unit, for every successfully detected photon that comes into this unit is going to generate an electrical pulse. This electrical pulse is then going to be output through this BNC coaxial cable and go to this Arduino circuit here. So what this Arduino circuit is going to do, it's going to run what we call a state machine. This state machine is very simple. It's a power up, it is going to switch the lamp on, and it is then going to count up to a set number of photons. In this case it's about 200,000. So when we've collected or counted more than 200,000 pulses from this single photon detector unit, the state machine is then going to switch this light bulb off. It is then going to wait for half a second, and then the process will repeat again. Now, there are a few slight caveats to this circuit to get it to actually work with an Arduino Nano. And the largest one is that the electrical pulses that this produces are quite short, about 9.5 nanoseconds. So what I've added essentially is a divide the frequency by 2 of those pulses, such that to stretch the positive pulse width such that it can be successfully counted by this Arduino Nano. And just to prove that this is actually working, if I place an object in the optical path, we should be able to see that the incandescent lamp stays on for much longer, which it indeed does. And in fact, if I carefully adjust the ND filter, this variable ND filter, I should be able to essentially speed up the rate of the flash by reducing how long the on period, or how long this incandescent lamp stays on for. But unfortunately it's not that noticeable. So, many thanks for listening.